Now let's get into our foldable 5.1 graphing polynomial functions. The first thing that we want to do is just remember what we just talked about in the last video, that end behavior is how a function behaves as x approaches positive infinity and as x approaches negative infinity. And so this is going to be determined by our degree and our lead coefficient. We'll have 4 cases to look at here because our degree could be even or odd, and our leading coefficient could be positive or negative. So that's going to give us 4 combinations. So for this first case here in the left-hand side, our degree is odd and our leading coefficient is positive. So if we have a degree that is odd and a leading coefficient that is positive, that positive leading coefficient, remember, tells us that the arrow on the right hand side is going to go up. Remember that the leading coefficient always tells us what happens on the right hand side. The fact that our degree is odd tells me that the left arrow needs to be opposite. So the left arrow is going to go down to be the opposite of the right hand arrow. Okay, so based on that, I can draw a little sketch of a odd function. Now I'm going to draw a third degree function. It basically has a couple of times where it makes a turn and goes the other direction. So I know I need to start with a function that's headed towards negative infinity because that's what happens on the left. But then it's going to turn at some point and come back around to head up towards positive infinity. So this is just a generic, say, third degree polynomial, something with an x to the third as its highest power. So let's summarize what's happening. I know we've drawn the arrows for it, but let's write it kind of in our official math speak. So on the right hand side, as x approaches infinity, because we know that on the right is where x is headed towards infinity, we're going this direction, then what's happening with our function? Our f of x is also headed towards infinity because our arrow is going up towards positive infinity. Remember, right and up are both positive infinity. So this is what's happening on the right-hand side. On the left-hand side, remember that that's opposite because we had an odd function. So over here on the left, I'm going to say that as x approaches negative infinity, because that's where x heads as we go to the left, f of x, our function, is going to be going down towards negative infinity as well. So that's what's happening on the left and the right of that function. Now we're going to go ahead and look at a case where we still have an odd degree, but now we have a negative leading coefficient. So that negative leading coefficient tells us that on the right-hand side, our arrow is going down. So we're down on the right. And remember that our degree, being odd, tells us that the left arrow is doing the opposite thing of the right-hand arrow. So on the left, our arrow is pointing up this time. All right, so based on that, I can draw a rough sketch, again, of a third degree polynomial, something that has an odd degree. And this time I know that on the left-hand side, my arrow needs to point up, and then it will come around and my arrow will point down on the right-hand side. So let's go ahead and write this in our official math language. Let's first talk about what's happening on the right. So on the right, as x approaches infinity, so remember we're headed to the right, so our numbers are getting bigger and bigger and bigger as we head towards infinity. Our f of x function, our y values, are headed towards negative infinity because we have that down arrow right here. Okay, so that's what's happening on the right-hand side. So on the left, as x approaches negative infinity, if we're going to the left, we're always approaching negative infinity, then f of x is approaching infinity because our arrow is going up here on the left.